Hello everyone, I'm Anish and today we will be solving this interesting question on diode and a capacitor circuit, right? So we have been given this circuit and we have to find the average output voltage for the following two cases. When the diode is idle, that is the cut-in voltage of this diode is 0, and when the diode has a cut-in voltage of 0.7 volts. So how should we proceed in this question, right? So for the first case, right, when the diode is idle, we should write for the case 1 when the input is here it's 6 volts, right? So I didn't talk about the input is swinging from 6 to minus 5 volts as a square wave, right? It is not symmetrical. Okay, so case 1, when Vi equals to 5 volts, right? So initially 6 volts. Vi is initially 6 volts. So let me draw the circuit. This is 6 volts, this is the capacitor, this is the diode, and this is VO, right? And initially what the capacitor has, it is uncharged, nothing is said about the capacitor, so it will be uncharged, right? So initially this cap has 0 volts of charge. Now what will happen? This has 0 volts of charge. Let us assume that the diode is off, right? We will assume that diode is off. So this 6 volts will come to the anode of this diode, and this is grounded, right? We will assume this has common ground. So this is grounded. So anode is connected to the plus terminal. So this diode will turn on. What happens after this diode turns on? So when this diode turns on, right, the circuit replaces like this only, and a constant voltage source is connected across the capacitor. So what will happen? Obviously it will get charged instantaneously and infinite current will flow through this circuit, right, at t equals to 0 plus. So an infinite impulse current is flowing. So this capacitor will get charged instantaneously and it will be get charged to 6 volts. So what will happen after that? After that it will reach steady, the capacitor will reach steady state, right? So the current through the capacitor becomes 0, hence the diode again turns off as the current is 0 in the circuit, right? So it turns off. Okay, but it is charged to 6 volts. So what is happening? What is the VO? So what is the VO? So VO equals to, let us write the KVL from here, right? If I assume a voltage source from here, from this VO. So what is VO? This is minus VO minus 6 plus 6 equals to 0. So VO comes out to be 0 volts, right? VO comes out to be 0 volts. How am I writing minus VO? Just plot it like this. This is plus minus VO. This is not a voltage source, this is a measurement. We are measuring the voltage. Okay, that's why I write the minus VO. Okay, so basically this is the VO for case 1. Now let's go for the case 2. Okay, case 2, when Vi equals to, in second case, right, it is going to minus 5 volts for t by 2, minus 5 volts, right? Now if it is going to minus 5 volts, so let me replace the circuit again. This is this is 5, I've changed the polarities, and this time the capacitor has some charge, right? This time it has 6 volts of charge. So let me write it like this, 6 volts, and again I will assume that the diode is off. Okay, now if the diode is off, right, now what is this is the common ground, right? Now what is the voltage across the anode of the diode? So the voltage across the anode of the diode is VA, basically it is equals to minus 11 volts, right? You can write the KVL, it is equals to minus 11 volts. So we can see that it is negative voltage, so obviously the diode won't get turned on, so it is in reverse bias. So diode is reverse bias. Here initially diode was forward bias. Okay, so here it is reverse bias, so obviously it won't get turned on, so no current will flow through the circuit, so everything will remain as it is, right? So the capacitor won't change its voltage, so the circuit will look something like this only. Five volts, and this is open circuit, and we're measuring the voltage from here, right? So what is the VO this time? VO is basically that anode voltage, which is basically minus 11 volts. So VO in the case 2 is minus 11 volts. Now what is happening in case 3? When again the square pulse goes to plus 6 volts, right? What is happening there? So case 3. So for case 3, right, let me draw the circuit again. This is plus minus 6 volts, and the capacitor this time again has same charge, 6 volts, and this is the diode, right? This is the diode, and this is the VO. Now what is happening here is, one thing you can notice, even if you assume that the diode is on, like the anode to cathode voltage is 0 this time, right? You can calculate anode to cathode voltage is 0. Even if you assume that the diode is on, what will happen, as the capacitor is already charged to 6 volts, no current will flow, right? No current will flow, as this is also 6 volts, so it satisfies the KVL, so no current will flow, hence like it is in steady state, so current through the diode is 0, hence the diode will be off. So even if you assume it is on, we can see that final result is coming as off, right? Because this is in steady state, as no current is flowing through the circuit, right? So it will again, what is VO? VO will remain to 0 volts only, right? It will remain to 0 volts only. So like now we can plot the waveform for the output voltage. So again in the fourth case, what will happen? Same case, like this only, it will be minus 11 volts. Okay, so let us plot the output voltage waveform. Okay, so what is happening? This is T, this is VO, right? So initially what is happening? Initially there was some impulse current which we won't be able to show it here, and VO, like initially for a certain second VO was like plus 5 volts, right? VO was plus 6 volts, because this was 0 volts and VO was directly connected to this. So for certain seconds it went to 6, then it went to 0, like at same instant, right? At t equals to 0, as the capacitor got charged instantaneously. So we won't show that 6 volts here, we will only show 0 volts. Okay, 0 volts, then it went to minus 11 volts, it remained there for a half time period, then again to 0 volts, and then minus 11 volts, right? Minus 11 volts and 0 volts. Okay, so this is basically happening. So what we have been given to find out is the average output voltage, right? Average output voltage. So what is the average of this waveform? So V out average equals to 0 times T by 2 plus 11 times T by 2 divided by T. It is basically 5.5 volts. So this is basically it for the first case. Now let's go for the second case. When, let me write it, when VD on equals to 0.7 volts. Okay, so when VD on equals to 0.7 volts, what can we tell by intuition, right? By intuition what we can tell is, let me like take the circuit here. By intuition basically we can see that the whatever this input source is charging, right, this needs an extra 0.7 volts, and the remaining point, like other than the 0.7 volts, this will get charged. So this will get charged to less, like by a lesser amount, right, than the previous. Like previously what was it getting charged to? It was getting charged to 6 volts, right? The capacitor here, it was getting charged to 6 volts. Now as the diode is also an extra drop component for this input voltage, right, it will get charged to only 5.3 volts, and it will get charged to like not charged, it will be replaced with a 0.7 volt voltage source. So this will get charged lesser amount. So obviously the V out, right, V out will get shifted to plus 0.7, because this is plus 0.7. So V out will get shifted to plus 0.7 volts. Hence the average voltage, what will happen to it? It will also get shifted by plus 0.7 volts, right? So we can prove it by like again like solving for the cases, right? Now let's go for the first case. Let me going for the next page, case 1, right? When I will do it a bit fast this time, because we have already solved it, right? So let me bring the circuit here and replace this is 6 volts, right? Now this time the diode will get replaced, right? Diode will get replaced. So let me replace the diode. As like we can see, initially the capacitor was uncharged, so like anode has positive voltage, so it will turn on. So it will turn on, it will have 0.7 volts, right? So if it has 0.7 volts, so what will the capacitor get charged to? So capacitor this time will get charged to 5.3, right? Simple use the KVL, right? Simple use the KVL, you can see it will get charged to 5.3. So what is the VO this time? So what is happening after this is the diode will get turned off after this, because the capacitor reaches steady state, it instantly reaches to 5.3 volts. Then what is happening? Then obviously like no current will flow, right? If no current flows, let me draw the circuit. The circuit is looking something like this, 6 volts, okay, and this is V out. So no current is flowing, right? No current is flowing, so this will remain at 5.3 volts, okay. This will remain at 5.3 volts. Now what is the voltage across the diode? Like it is 0.7 volts only, but we will assume it as off because no current is flowing, right? No current is flowing, so the diode is off. So what is V out? It will be 0.7 volts, right? Like simply apply the KVL from here, it will be 0.7 volts. Now for the case 2, right? Case 2. This time the Vi is minus 5 volts. This is minus plus 5. This is the capacitor and this is charged to 5.3 volts, right? Plus minus. This is the diode, okay. This is a view. Like from here we can see that obviously the anode is connected to the negative terminal, or like to negative potential, so hence this diode won't get turned on. So what will be the voltage this time? V out, it will be simply shifted by 5 volts in the downward direction. So minus 5.3 minus 5, which is equals to minus 10.3 volts. So V equals to minus 10.3 volts, right? So now like for the case 3 also similar thing will happen. Like again it will get it will be steady state and the capacitor will be only at 5.3 volts. So let me plot the like output waveform, right? VO. So what is happening? Initially it is 0.7, then it is going to minus 10.3, then again it is remaining at 0.7, minus 10.3 at 0.7 volts. This is minus 10.3. So you can check it for yourself, it's just getting shifted by 0.7, right? So the average voltage will also get shifted by 0.7, or you can do the calculation basically. Pi t. So this is basically 0.35 minus 5.15, which is equals to minus let me write this properly, minus 4.8, okay, volts. So we can see that the average voltage has been shifted by 0.7 volts. So like basically what we did in this question, if you want to solve this very quickly, right, very quickly, what you can do is first check, we have plus 6 volts here, this capacitor is uncharged, so this whole plus 6 volts will come across this anode, diode will get turned on. This is just a voltage source directly connected across a capacitor, so this will instantly charge the capacitor, so this will reach 6 volts and this diode is like off, right, then off. So what is the VO? VO is basically minus 6 plus 6, so VO is 0 for the first case. For the second case, right, what is happening? For the second case, basically we are getting minus 5 volts here and this diode will never get turned on because this was already negative and this became negative also, so the anode obviously is in a lower potential, obviously it will never get turned on. So again we'll just use a simple KVL, it is minus 11 volts. So how can we calculate the average? For the first half it is 0, for the second half it is 11, so obviously the average voltage will be half of the overall value, right, 11 by 2, so it is 5.5. and for similarly for the like diode case, in an ideal diode you can solve for that. Now what I will give you as homework is solve it when this diode has like a linear piecewise model. Basically this diode has a like on resistance also. Solve for that case. Okay, take the on resistance as like 1 ohm and capacitor as like 1 farad. Okay, and like solve for when the time period is like what do you say, 5 seconds or something. Okay, then solve for the question. Okay, thank you for watching this video, and please hit the like button if this video helped you guys. Thank you.